The James Webb Space Telescope, the most advanced observational instrument ever developed for cosmic exploration, has not merely refined our view of the universe, it has destabilized long-held assumptions that underpin the human understanding of reality. What began as a technological achievement soon evolved into an epistemological crisis. The data returned by Webb suggests a cosmos far more structured, dynamic, and possibly intentional than previously imagined. With each observational campaign, it appears increasingly plausible that the universe is not the silent, indifferent expanse modern cosmology assumed, but something layered with anomalies, signals, and possibly communication. The significance of this shift lies not just in the scientific findings themselves, but in the philosophical implications that follow. The idea that the universe may contain signatures of intelligence, or at least organization beyond random chaos, represents a tectonic movement in human thought. Historically, cosmology was rooted in a materialist framework space, as a vacuum, governed by blind forces and predictable laws. What the Webb Telescope reveals challenges that paradigm on multiple fronts. Consider the first major anomaly Webb reported: a rapid and unexplained cooling of Neptune's upper atmosphere. This is a planet that lies on the outer edges of our solar system, largely stable and frozen in both spatial and energetic terms. Over decades, data from Voyager 2 and ground-based observatories established an atmospheric baseline, yet Webb detected a cooling of nearly 10 degrees Celsius, absent any corresponding solar fluctuation or internal geophysical activity. Further complicating the mystery were shifts in Neptune's magnitude, a pulse without a known heart. This observation, seemingly localized, is the first indication that planetary bodies might be subjected to forces unaccounted for in current astrophysical models. Whether such forces are gravitational, quantum, or perhaps even artifacts of an intelligence or non-random influence, remains indeterminate. Yet the mere suggestion of planetary scale manipulation or modulation opens a philosophical abyss. If planetary behavior can change without proximal causes, then the causality matrix we apply to cosmic dynamics is incomplete. And if incomplete, possibly as Webb extended its reach to the TRAPPIST-1 system, the questions intensified. Here, 7 rocky planets orbit a red dwarf star, 3 situated within the classical habitable zone. Webb's infrared spectroscopy confirmed water vapor in 2 of those atmospheres, 1D and 1E0, as trace elements, but in quantities suggesting dense humidity and potential cloud systems. These characteristics, coupled with stable temperature gradients and orbital resonance patterns, support a model of ancient, planetary-wide oceans. Furthermore, the detection of ozone-like compounds biosignatures on Earth suggests that these atmospheres are chemically active in ways we associate with life. This is not a mere confirmation of habitability, it is a redefinition of what it means to be alive on a planetary scale. The presence of potential biological indicators on multiple worlds within the same system contradicts the probabilistic rarity of life as traditionally conceived. Until now, the emergence of life was treated as an improbable convergence of conditions. Webb's findings suggest that such convergences might not only be probable, but systemic under certain stellar arrangements. And if systemic, then life may not be the exception, it may be the rule. It is here that we must insert a moment of reflection. These revelations are not abstract. Astrophysical details, they directly challenge humanity's central existential assumptions. If the universe is teeming with planets capable of supporting life, if water-rich atmospheres and biosignatures are not rare but recurrent, then humanity is not special in the way once imagined. The anthropocentric model collapses under the weight of statistical probability. And if intelligence is not uniquely human, then observation itself may be a two-way process. If you're still with us at this point, it's a sign that these ideas resonate deeply. Pause for a moment, leave a comment below. What do you believe? Is the universe watching us back? Share your thoughts. And don't forget to like this video and subscribe to the channel so you stay informed as the Webb Telescope uncovers even more astonishing data. The philosophical consequences continue when we turn to Webb's deep field observations, particularly of galaxy JADES GSZ 1320, estimated to have formed just 330 million years post-Big Bang. The radiation emitted from this galaxy, notably in the Lyman alpha band, is inconsistent with existing models of early universe hydrogen opacity. This signal was neither absorbed nor scattered as expected. Instead, it was clear and coherent, as though the hydrogen through which it passed had already been ionized long before such a process was supposed to occur. This single observation rewrites the timeline of the epoch of reionization, a pivotal phase in cosmological evolution, wherein the universe transitioned from darkness to transparency. If light the soul travels unobstructed, it implies that ionizing processes were active significantly earlier than current models allow. The implication here is double. Either our understanding of the physical conditions in the early universe is flawed, or some unknown factor accelerated the transparency of the cosmos. This factor may be energetic, structural, or in the most speculative. The possibility that cosmic engineering may have occurred in the early universe introduces a radical hypothesis. Perhaps some form of intelligence preceded us, seeding the structure of space itself. Skepticism is natural and necessary. Astrophysics, like all sciences, must resist unfalsifiable claims. Yet when observations deviate repeatedly and significantly from predictions, the scientific method requires adaptation. Dismissing these patterns as statistical flukes becomes increasingly untenable. If early galaxies emitted light that should have been absorbed, but wasn't, we must ask whether our current models describe a complete cosmology or merely a convenient approximation. This theme, survival against odds, or persistence in contradiction, emerges again in Webb's analysis of white dwarf systems. The transition of a main sequence star to a white dwarf is an explosive, entropic finale, annihilating nearby planetary bodies. Yet, in the system WD-1856 plus 534, Webb detected a gas giant orbiting in close proximity to the stellar remnant. More than survival, this planet exhibited signs of atmospheric adaptation. Vaporized water and sulfur compounds suggested chemical regeneration in response to stellar death. This phenomenon reopens a debate, long considered closed: the temporal bounds of habitability. If a planet can survive the death of its star and reconfigure its atmospheric chemistry to persist under new conditions, then the life cycle of life-friendly environments extends far beyond main sequence. It introduces the notion of post-stellar ecosystems, worlds that do not die with their suns, but transform, adapt, and perhaps even foster life anew in residual warmth and radiation. Such systems would be the ideal habitats for forms of life evolved to endure entropy. The philosophical inversion is staggering. Stars were always considered the sources of life. Now they may be its precursors. A dead star, long deemed the final note in a planetary symphony, might merely be the overture of a deeper melody. If this is the case, then we must acknowledge a broader principle. Survival in the cosmos may not rely on abundance of energy, but on adaptability to scarcity. Intelligent life, in this frame, is not defined by its environment, but by its ability to extract meaning from entropy. Another dimension of mystery arises from the cold corners of our own solar system, where Webb's infrared mapping revealed unexpected heat signatures on small, irregular moons of Uranus and Neptune. Hippocamp and Despina, long considered geologically dead, displayed thermal patterns inconsistent with their size and expected composition. Even more startling was the presence of complex carbon compounds. The standard models offered two explanations: residual radioactive decay or tidal heating, yet neither fully accounts for the observed organization of carbon structures. This leads to a third, unsettling possibility: external seeding. If these moons have been planted with complex molecules, we must consider that they might be relics of a broader distribution strategy, whether by natural mechanisms like panspermia, or by intelligent actors conducting cosmic-scale experimentation. The implications are staggering, not because they contradict known science, but because they extrapolate logically from it. Carbon compounds do not spontaneously organize under cold, high radiation conditions without an energy source. If no endogenous energy exists within the moons, then energy and structure must have come from without. This reorients our understanding of planetary bodies. They are not isolated geological accidents, but potential nodes in a galactic network. As our instruments peer deeper, the trend becomes impossible to ignore. Webb's discovery of an infrared signal from the core of Messier 82, a known starburst galaxy, showed rhythm, modulation, and mathematical structure. It matched no known natural pulsation. SETI frameworks have long proposed that artificial signals would appear exactly like this: repetitive, mathematically spaced, and non-random across spectrums. No definitive conclusion has been issued publicly, yet off-record comments from researchers indicate unease. If the signal is natural, it belongs to a class of phenomena yet unclassified. If it is artificial, then it implies a capacity for interstellar broadcasting at a galactic scale. Either way, our linguistic categories natural and artificial, random and deliberate no longer suffice. A new ontological vocabulary may be required to interpret a universe increasingly indifferent to human conceptual limitations. From Neptune's cooling pulse to Messier 82's signal, from TRAPPIST's humid atmospheres to post-stellar planetary survival, James Webb is not merely capturing light. It is confronting humanity with the persistent suggestion that the universe is not a vacuum, but a canvas. Not silent, but encoded. Not empty, but structured in ways that resist reduction. The telescope functions as a philosophical instrument, as much as a scientific one. It does not merely show us what is out there, it forces us to ask why we are able to see it at all. We must then confront a final dilemma. In our pursuit of understanding, have we inadvertently glimpsed truths we were not prepared to receive? And more disturbingly, are these truths meant for us at all? As the veil lifts, our species may be awakening not to its place in the cosmos, but to the fact that it was never alone beneath the stars. As the James Webb Space Telescope continues to push the boundaries of cosmic observation, it reveals a universe layered with depth, nuance, and contradiction far beyond the limits of any single scientific discipline. The revelations are not linear extensions of existing theories, but represent categorical upheavals that force a redefinition of what constitutes evidence. Life, time, and even space itself. Each dataset Webb returns seems less like raw information, and more like a piece of a much older, incomprehensibly vast system, perhaps not designed for us, but discoverable by us. In this second tier of implications, the telescope confronts humanity with not just what is observable, but what is concealed. One of the most disconcerting discoveries arises from Webb's observation of Ki, popularly known as Tabby's star. Previous telescopic surveys already registered irregular dimming patterns in its light curve, prompting a wave of hypotheses ranging from interstellar dust to but none fully accounted for the periodic geometric nature of the light reductions. Webb's instrumentation, far more precise than anything deployed before, revealed that the occlusions were not stochastic. Instead, thin, angular objects transited the star in intervals so regular and precise that they resembled the mechanics of an engineered system. These were not clouds or planetary debris fields. Their passage was too clean, too sharply defined in both amplitude and duration. Moreover, Webb detected low-frequency waste heat emissions in the surrounding space, anomalous infrared radiation, inconsistent with the star's output. On Earth, such waste heat is a byproduct of energy usage. Its detection around Tabby's star implies that something might be harvesting energy and radiating excess heat, perhaps a sign of a large-scale technological infrastructure. The term Dyson swarm, once relegated to speculative fiction, is now entertained as a working hypothesis among certain astrophysicists. The implication is not merely that intelligence may exist elsewhere. That idea, in isolation, is almost banal. The deeper issue is the scale. Dyson swarms, or similar constructs, suggest a civilization capable of manipulating planetary orbits, stellar emissions, and possibly time itself. This is not life as we understand it, it is engineering on a cosmic level. And in contemplating such phenomena, the limitations of human we must ask not simply whether we can detect such structures, but whether we possess the cognitive architecture to recognize them for what they are. After all, how does a finite intelligence apprehend the purpose of something built with posthuman logic? In parallel to these external cosmic inquiries, Webb turned its attention to the gravitational lensing effects of the Pandora cluster. The cluster itself is a known tool in observational astronomy, acting as a magnifying glass for light from ancient galaxies. However, this time, during prolonged exposures, something unprecedented occurred. Moving shadows crossed the background galaxy fields. These were not instrumental glitches or pixel noise. They were verifiable occultations of distant light sources. Yet nothing was visible in the spectral range that would explain them. In astrophysics, shadow implies presence. The fact that these occluding objects emitted no light, reflected none, and left no signature, except for their interference, suggests a material type fundamentally different from anything currently classified. These were not just dots, they were stealthy, invisible, even to the near-infrared sensors of the most advanced telescope ever created. The hypothesis emerging is unnerving. These might be non-reflective megastructures, perhaps vessels, or remnants of technology designed to evade detection. The epistemic consequences are severe. Until now, invisibility in astrophysical terms meant absence or insufficient resolution. This forces a re-evaluation. What if invisibility is a function of intentional design, not a gap in measurement, but a feature of the object itself? In such a model, observation becomes a strategic act, and the observer a potential participant in a system of disclosure and concealment. The cosmos ceases to be a passive arena and becomes something interactive, responsive, perhaps even hierarchical. These theoretical constructs introduce an unsettling question. If there are intelligences capable of concealing entire structures from our most advanced instruments, then their awareness of our capabilities must exceed our own. This implies not only intelligence, but surveillance. The role of humanity shifts from passive observer to observed entity. The telescope does not merely look out, it may be indirectly looking in. What we see may be contingent on what we are permitted to see. As these implications compound, we encounter a philosophical bias. There are two primary interpretive frameworks one might adopt. The first is expansionist, the belief that these anomalies are discoverable, comprehensible, and ultimately solvable within an extended version of our current scientific models. This is the dominant framework within mainstream science. The second framework, however, is rethink. It argues that these anomalies represent the limits of the scientific method itself, that the phenomena observed are not merely outliers but fundamentally beyond the descriptive and predictive power of our existing theories. Under this lens, the universe is not waiting to be decoded like a machine, but instead operates with dimensions of meaning inaccessible to a species trapped in space-time and causality. This second interpretation aligns with what many philosophers have called the ontological shock, the dissonance that arises when reality contradicts foundational beliefs so completely that no theoretical patch can reconcile the difference. Webb's data appears to induce this shock repeatedly, not because it disproves known theories, but because it shows the presence of an intentionality or organization where none was expected. Structure without precedence, behavior without agents, design without designer. Consider again the case of exoplanet atmospheres, rich in water vapor and bios. It is not merely the existence of such planets that is shocking, it is their statistical clustering, that in a small, observable slice of the galaxy, we already find multiple candidates for life-supporting conditions suggests an abundance we were unprepared for. Either we have stumbled upon an anomaly, or our prior sampling was catastrophically biased. If the latter, then life is not a product of luck, it is a function of nature. Its emergence is written into the chemical and energetic equations of planetary development. And if life is common, intelligent, yet herein lies the paradox. While Webb finds atmospheric markers, infrared pulses, and dark structures, it finds no messages, no communicative intent, no artifact of cultural self-reference. The data is all structure, no syntax. This leads to an important hypothesis. Perhaps we are not meant to understand what we are seeing. The signals we detect may not be addressed to us, nor even to any intelligence. They may be side effects, or residues, or traces of processes operating at ontological levels above what we can parse. In this frame, meaning is neither absent nor present, it is or. To illustrate, consider language. A sentence can be composed of coherent words, grammatically arranged, yet remain semantically opaque to someone lacking the cultural context. If an alien language were composed, not of phonemes or symbols, but of gravitational fluctuations or radiation pulses, how would we translate it? Would we even know it was a language? Webb may be detecting such expressions, systemic outputs not designed for communication, but still marked by regularity, modulation, and repetition. Like watching shadows flicker on a wall without ever seeing the fire behind them. The final, and perhaps most disturbing, pattern that emerges from Webb's findings is one of concealment. From Neptune's magnetosphere to the dark objects in Pandora's lens. From the unaccounted infrared pulses to the waste heat around Tabby's star. The consistent element is that something is always just out of reach. Not absent, but obscured. The cosmos, once thought indifferent, now seems evasive. And this evasiveness feels strategic, which raises a possibility long whispered in speculative circles, that the universe is not merely filled with intelligence, but that intelligence actively resists detection. That there exists a set of principles or conventions, cosmic or technological, by which advanced entities hide their presence. The anthropological analogy would be the principle of non-interference, often invoked in science fiction but grounded in ethical reasoning. If intelligence exists at scale, perhaps concealment is not a limitation, but a responsibility. The James Webb Space Telescope may not be exposing alien civilizations, but it is revealing the scaffolding they might leave behind. It shows us the cosmic ruins, the thermodynamic graffiti, the gravitational echoes. It suggests that reality itself might be scaffolded by processes we neither designed nor yet understand. And more importantly, that we are surrounded by those processes every moment inside planetary atmospheres, in stellar emissions, in the dark bands of the cosmic background radiation. If you've made it this far, your curiosity already places you in a rare category. Let your voice be part of this unfolding dialogue. Drop your thoughts in the comments below. What do you think is truly happening out there? If you haven't yet, hit the like button and subscribe to the channel, because what comes next may very well change everything we thought we knew about the cosmos. Returning to the broader scope, the telescope's role shifts from passive recorder to active disruptor. In doing so, it fulfills a role once reserved for philosophy itself, challenging assumptions, proposing questions without answers, revealing truths too large for synthesis. Webb, like all revolutionary instruments, performs a deconstruction of human arrogance. We once believed the stars to be fires in a dome. Later, we called them nuclear furnaces, then gravitational wells. Now we begin to see them as nodes in a system too vast for monologue. We are no longer the center, not of geography, not of biology, and perhaps not even of perception. To observe the universe with such clarity and still remain blind would be the final tragedy. But perhaps this is not blindness, but apprenticeship. Perhaps the Webb telescope is not the end of human exploration, but its proper beginning, because, for the first time, we are not just gathering data. We are being asked to interpret it, and that interpretation, in all its philosophical weight, might one day allow us to transition from silent witnesses to conscious participants in whatever deeper logic governs this cosmos. The implications of the James Webb Space Telescope's findings do not end at scientific curiosity or wonder. They catalyze a transformation in our existential framework. We are now required to think of the universe not only as vast, but as layered, encoded, and perhaps even self or not through metaphor, but through the empirical trace of structures and behaviors that defy conventional cosmological explanations. In this third expansion of thought, we are driven to reevaluate time, entropy, and the very notion of cosmological agency. Time, traditionally viewed as a linear metric along which entropy increases and complexity decay, faces inversion under Webb's lens. The discovery of structured radiation from early galaxies, light that should have been absorbed by neutral hydrogen, but instead traveled unimpeded, reached thermodynamic equilibrium far earlier than expected. This equilibrium is not simply a passive state, but one that implies organization. Galaxies formed in impossible conditions. Radiation escaped where it shouldn't have, and structure appeared where chaos was predicted. From this arises the hypothesis of accelerated reionization, an era previously believed to have unfolded gradually, now appearing to have occurred in compressed temporal intervals. Either the early universe developed faster than physics allows, or it was acted upon. The or in that equation reopens ancient philosophical debates about teleology and nature, about the distinction between process and purpose. If the early universe behaves as though shaped, then physics alone may not be the sole arbiter of cosmic history. The boundary between what occurs and why it occurs is eroded. This erosion continues when we observe not ancient galaxies, but ancient mechanisms. The role of entropy, as the universal decline toward disorder, becomes contested. When Webb detects planetary atmospheres regenerating around white dwarfs, these are not merely survival mechanisms. They are examples of order arising after catastrophic collapse. Traditional thermodynamic models would predict stasis or decay. Instead, we find this raises a profound philosophical inversion. Entropy is not an end, but a phase. Perhaps complexity does not die, it changes form. This alone necessitates a re-evaluation of cosmic finality. If planets can adapt after stellar death, and if molecules can reorganize in frozen moons millions of kilometers from the sun, then perhaps our models of life cycle, stellar, planetary, and biological, are based on too narrow a conception of energy and time. What appears to be the end might be a metamorphic beginning. The metaphysical consequences here are not speculative, they are foundational. Consider the possibility that the universe possesses a logic of recurrence, not one of decay. Webb's data suggests patterns that are not transient anomalies, but repeated motifs. Thermal pulses in cold bodies, atmospheric biosignatures in hostile systems, rhythmic infrared signals in chaotic galaxies. These patterns point not only to processes but to templates. They imply that the universe may operate with modular, recurring architectures, not identical repetitions, but structural, like the Fibonacci sequence in biology, or harmonic ratios in acoustics. Such regularities may reflect a deeper algorithm embedded within the cosmos. If these patterns are real, then what we perceive as randomness may simply be ignorance of the code. The implications are mathematical, yes, but also epistemological. The universe may be deterministic in a way that current physics only approaches. The concept of randomness, long invoked to explain quantum behaviors or cosmic distribution, begins to resemble a placeholder for missing variables. And if missing, these variables may be relational, not measurable, existing in the logic of systems, not in the properties of particles. This systemic view finds reinforcement in Webb's observations of small moons exhibiting internal heat and chemical complexity. These are objects with no business being alive, not in a biological sense, but in a dynamic one. Their orbits are erratic, their sizes too small for sustained heat, their surfaces battered and barren, yet they pulsed with infrared energy and display the molecular foundations of organic matter. This juxtaposition dead form with living either our understanding of planetary geology is broken, or something else is maintaining activity within them. And once again, the specter of externality looms. If radioactive decay or tidal forces can't account for these patterns, then the possibility emerges that such moons are not entirely natural. They may be repositories, carriers, instruments. It is not necessary to conclude intelligent, designed to reach this hypothesis only, that some physical processes are being directed or whether by unknown mechanisms or by intelligent agents is, for now, immaterial. The key realization is that stasis in the universe is illusion. Everywhere we look closely, we find movement, response, configuration. This realization touches on perhaps the deepest philosophical theme to arise from Webb's mission: agency. Not merely biological agency, but cosmological agency. If systems self-organize, if entropy is reversible, if early galaxies appeared too early and too structured, then we are forced to ask whether the universe acts, not metaphorically, not mystically, but operationally. Agency here does not imply consciousness in the human sense. It implies directionality, preference, constraint, the same qualities that define intelligence in systems. In traditional philosophy, agency belongs to subjects. Stars are objects. Planets are objects. Only organisms and, particularly humans, are subjects. But this dichotomy begins to dissolve when we observe behaviors in non-living systems that resemble adaptation, self-regulation, and even anticipation. If a planet rebuilds its atmosphere after stellar collapse, if molecules cluster into complexity without external input, if light travels through impossible channels, then perhaps we need a broader taxonomy of agency, one that includes non-biological actors. Webb may not be showing us aliens. It may be showing us that our concept of the alien is too narrow. The truly alien may not build cities or send radio signals. It may be processual, expressed in configurations of matter, in thermodynamic cycles, in gravitational lattice. The alien may be the rule, not the exception. Not a visitor from afar, but the very medium through which reality unfolds. This challenges not only our science, but our metaphysics. To think of the universe as intelligible, but not interpretable, is a paradox, yet this is the condition Webb has placed us in. We receive data structured, repeatable, anomalous, and lack the reference to understand it. It is like reading a grammar without vocabulary. The syntax is there, but meaning eludes. And this, perhaps, is the clearest sign that we have encountered the boundary of our epistemological framework. In response, humanity must choose between two paths. One is defensive, to restrict interpretation to known models, to dismiss anomalies as outliers, to preserve the stability of existing paradigms. This is the path of historical orthodoxy. The other is integrative, to expand our conceptual repertoire, to develop new models of causality and intelligence, and to accept that the universe may contain categories of existence we have not yet defined. This latter path is not speculative indulgence, it is scientific necessity. Every major advancement in physics has come not from refining known equations, but from rethinking the variables. Newton, Einstein, Planck expanded the field by redefining its dimensions. Webb's data demands the same. Not new measurements, but new measurements of meaning. The telescope is not just a sensor, it is a philosophical provocation. Let us return to the theme of observation. Throughout history, observation was a one-way act, humans looking outward. But Webb's revelations invert this model. The cosmos appears responsive, not in a mystical sense, but in the sense that certain phenomena only emerge under certain observational frameworks. The act of measurement affects the measured. This is true in quantum mechanics and increasingly appears true in cosmology. If observation changes outcomes, then knowledge is not passive, it is participatory. This participatory model aligns with certain interpretations of quantum theory, but Webb expands it to a cosmic scale. The question becomes not what is out there, but how does I look and shape what we see? In this model, perception and existence are entangled. Reality is not independent of consciousness, not because it depends on human minds, but because observation is an event-relational node in the web of being. The telescope, then, is not merely a tool. It is a participant, and through it, we become participants too, which leads to a final consideration, perhaps the most consequential of all. What if everything Webb reveals is not a discovery, but an invitation? What if the structured signals, the biosignatures, the impossible shadows, the coherent pulses, all of it is a mode of disclosure, not overt communication, but something subtler, a calibrate, a process by which we are slowly brought into alignment with a reality much older, deeper, and more complex than our species, a pedagogical cosmos, a universe that teaches through anomaly. If this is true, then every image Webb returns is a lesson, every dataset is a dialogue, every deviation from the expected is an instruction to look again. Think deeper, abandon simplicity. The telescope does not reveal truths, it reveals the limits of our truths. And in doing so, it points beyond them. If you've been following this inquiry and felt its impact, it's time to make your engagement count. Subscribe now and turn on notifications to follow this unfolding revelation. Share your interpretations below. What do you believe the James Webb Telescope is really showing us? Let's make this space a forum for deep, serious thought. In closing this segment of reflection, we are left with an unsettling yet liberating realization. The cosmos is not a book to be read, but a language to be learned. It speaks not in declarations, but in contradictions, not in certainty, but in structure. And we, as listeners, must tune ourselves not to the noise, but to the pattern. The James Webb Space Telescope has not merely opened a window, it has redefined the architecture of the room we thought we were in. The walls are wider, the ceiling higher, and the horizon infinite, not in distance, but in dimension. In such a universe, certainty is no longer possible, but meaning has never been closer. Within the accumulating body of revelations supplied by the James Webb Space Telescope, we begin to see a transformation not just in scientific interpretation, but in the architecture of human understanding itself. The familiar dichotomies, natural and artificial, physical and metaphysical, observer and observed, are no longer sufficient. What emerges instead is a third state, complexity that carries the imprint of agency without attribution, behavior without declared intent, and signals that imply meaning without delivering it overtly. We are not facing the challenge of decoding messages sent to us, but of interpreting a systemic coherence that may not be directed at us at all, yet affects us nonetheless. This realization places pressure on the structure of scientific realism, which has long held that the universe exists independently of observation and can be understood through objective inquiry. The data returned by Webb suggests instead that objectivity is an insufficient epistemological stance. The act of measurement does not merely reflect reality, it alters its behavior, particularly when examining systems at vast scales or extreme energies. This notion was already present in quantum physics, but Webb's cosmic scale observations reinforce it. The cosmos may exhibit participatory features, expressing one reality under certain observational constraints, and a different one when those constraints shift. Let us examine this through the example of gravitational lensing, long understood as a purely geometric distortion of light by mass. Yet Webb's observations complicate this model. In the case of the Pandora cluster, it wasn't merely light bending, predictably it was light interrupted, shadowed by non-emitting. If such phenomena recur, shadows without sources, occlusions without objects, they suggest not just failure of instrumentation or gaps in knowledge, but an entirely different kind of presence, one that exists to be unseen. Unseen, in this context, is not synonymous with absent. Rather, it suggests deliberate asymmetry. These are presences optimized for invisibility, possibly through properties of material physics we do not yet understand, or through technological means so advanced they mimic natural principles. The implications are profound. If some entities in the universe are designed to be then our map of reality is fundamentally inaccurate, not because it contains errors, but because it omits domains we are structurally incapable of perceiving. And here we confront a new ontological dimension. Concealment as a feature of the cosmos. In traditional physics, we speak of dark matter and dark energy as anodes with gravitational effects but no observable emissions. But Webb's findings point to something beyond these placeholders: active concealment, intentional opacity, possibly as a defensive or isolationist posture. If concealment is strategic, it implies a model of interstellar existence where interaction is avoided, not due to distance or difficulty, but as a normative behavior. Civilization, in this frame, does not expand to dominate, it recedes to survive. This concept is not new in speculative philosophy, but Webb renders it empirical. Consider the structured infrared emissions from the Cigar galaxy, Messier 82 pulses in mathematically consistent intervals, recurring in patterns with no natural parallel in other wavelengths. While some argue for neutron-starred or pulsar activity, the absence of corresponding X-ray or visible phenomena undermines those explanations. What remains is the suggestion of non-random emissions, too coherent for noise, too ordered for coincidence. We must then entertain the possibility that the universe is not merely inhabited, but encrypted. What we perceive as silence may be an artifact of the encryption key we lack. The phenomena observed, biosignature, unlike human language, which operates on semantic intent. This cosmic syntax may function structurally. Meaning is conveyed not through symbol, but through relation, frequency. In such a system, interpretation cannot rely on direct analogy. There is no Rosetta Stone, no transmission declaring intent. There are only patterns, and the mind's attempt to derive meaning through them. This is where the role of philosophy becomes indispensable. Science supplies the measurement. Philosophy supplies the frameworks within which those measurements can be interpreted. It is no longer enough to ask what we see. We must ask what kind of seeing we are doing. Are we witnessing phenomena or participating in a cosmological exchange? Are we receivers of information, or are we interacting with a structure that adapts as we do? This mutual adaptation finds a compelling analog in the TRAPPIST-1 system. Webb's detection of water, vapor, and ozone-like compounds in the atmospheres of multiple exoplanets within this single system defies the probability distributions long assumed in planetary formation models. The recurrence of habitable conditions in such a compact star system suggests a replicable biological scaffold built into the formation of planetary environments. If life is not a statistical anomaly, but a systemic expression of cosmic chemistry, then the presence of multiple potentially life-supporting planets in a single nearby system should no longer surprise us. What should surprise us instead is how long we have misunderstood the nature of life itself as fragile, improbable, and rare. Webb suggests the opposite. Life is the default condition when certain thresholds are met. And if this is true for life, might it also be true for intelligence? This question leads us to the philosophical core of the inquiry. What is intelligence in a cosmic context? If the cosmos operates with self-organizing principles, if matter and energy conspire toward complexity and a minimal constraint, and if these complexities generate patterns that can be modeled mathematically, then intelligence may be a property of systems, not just minds. It may arise wherever organization reaches a certain density, not as a discrete being, but as a distributed capacity. In this frame, galaxies, planetary systems, even molecules may possess rudimentary forms of intelligence, but responsiveness to context, optimization under constraint, feedback-driven adaptation. What distinguishes human intelligence, then, is not its uniqueness, but its localization. We experience intelligence as subjective consciousness. The cosmos may express it as patterned causality. The web of stars and dark matter might be not a theater, but an actor. Webb's data supports this interpretation indirectly but powerfully. The recurrence of structured patterns, the detection of atmospheric regeneration, the presence of dark but organized matter all suggest systems behaving in ways that exceed mere physics, not because they violate laws, but because they appear to exploit them. This is the essence of engineering, not opposition to nature, but its precise manipulation. Thus, we return to the earlier hypothesis, one that must now be framed not as speculation but as inference, that the universe may be engineered, not in a sense of a creation myth or a grand designer, but in a sense that its behaviors exhibit qualities we associate with constructed systems: redundancy, scalability, feedback, and failed. We may be living inside a structure that sustains its own evolution, alters its own parameters, and perhaps even experiments with its own rules. From this view, Webb's role is not observational, it is revelatory. Its function is not merely to gather light, but to expose the architecture behind the light. The telescope becomes a kind of diagnostic tool for reality itself, revealing subsystems and redundancies that would otherwise remain hidden. And through it, we glimpse a universe that is not only active and structured, but possibly a reflexive universe is one that not only contains observers, but includes observation as a causal factor. In such a model, the act of perceiving becomes part of the cosmological equation, not because consciousness shapes matter in the mystical sense, but because systems that are observed behave differently than those that are not, either through quantum interactions, informational entropy, or intentional modulation. This idea aligns disturbingly well with the behavior of certain observed systems. Tabby's star, for instance, exhibits dimming behaviors that became more anomalous the more they were studied. The possibility arises that observation itself is a threshold crossing. It changes the system. And if this is true at cosmic scales, then we must admit a shocking possibility, that the universe contains feedback loops of attention, and that Webb may be triggering one. Such a loop implies a participatory cosmology. Not that the universe is watching us, but that it is aware of being watched, at least at the level of process. This is not pantheism or anthropomorphism. It is systemic interaction. We build tools to see further, and the structure of what we see changes in response. Not because it cares, but because interaction is part of its function. Webb, then, is not just an extension of the eye, it is a component in a feedback network of reality. And perhaps this is the answer to the silence. The great silence, often referenced in discussions of the Fermi paradox, may not be due to the absence of life or intelligence, but to a kind of cosmic quorama principle of reticence that governs systems advanced enough to communicate. In this model, civilizations do not announce themselves. They resonate, they synchronize, they adjust parameters, they altered local entropy. Their message is not a broadcast, but an effect. We are now beginning to detect those effects, not through radio signals or alien artifacts, but through unexpected thermodynamics, unclassified occlusions, and improbable chemical patterns. Webb is the first instrument sensitive enough to register these effects in their full context. And as it does, it begins to fulfill a role that humanity has always projected onto myth, the revealer of what was hidden, the bringer of unseen truths. If these patterns continue, and if they remain consistent across regions and timescales, the burden of proof will shift. The denial of structured intelligence in the cosmos will become less plausible than its acceptance. We are approaching a point of inflection and epistemic event horizon. Beyond it, nothing about the universe will remain philosophically neutral. Everything will be implicated in meaning. At that moment, the question will no longer be, are we alone? But are we ready? Ready not for contact, but for consequence. For the rewriting of our frameworks, the redrafting of our definitions, the deconstruction of the anthropocentric bubble. The universe is not indifferent. It is patterned, and those patterns are now speaking not in language, but in law, in light, in structure. The James Webb Space Telescope is our bridge into that conversation. The universe, as now glimpsed through the unparalleled lens of the James Webb Space Telescope, no longer appears to us as a stage devoid of script or director. Instead, what emerges is a panorama filled with distributed intention processes that converge on complexity, behaviors that resemble coordination across spatial and temporal boundaries, and events that no longer sit comfortably within probabilistic frameworks. These observations compel a shift in how we conceive of cosmic systems, not as random fluctuations across an indifferent void, but as domains embedded within a deeper order, one not necessarily bound by anthropic utility, but observable nonetheless through consequence, through structure, and through emergence. A pattern has become unmistakable. Webb has revealed not one anomaly, but a cascading sequence of them, each one independently suggestive, but collectively overwhelming in implication. An unexplained thermal drop on Neptune, structured pulses from Messier, 82, biosignature compounds on multiple TRAPPIST planets, shadows with no source in the Pandora cluster, waste heat unaccounted for in Tabby's star. Taken individually, each may invite skepticism or dismissal. Taken together, they form an architecture of irregularity, what one might call a lattice of the unknown. This lattice does not require a conspiratorial reading. It does not posit that there is a singular intelligence behind the veil, orchestrating the symphony of the stars. Rather, it invites a framework in which intelligence is not a trait, but a continuum. Intelligence as configuration, intelligence as recurrence. What emerges from Webb's data is not proof of alien civilizations in the way cinema has led us to expect, but the far more disquieting possibility that civilization itself is not an endpoint, it is a substrate, a property of reality under certain energetic conditions. Such a view challenges every model of intelligence rooted in scarcity, in organic limitation, or in temporality. If Webb's discoveries suggest anything, it is that intelligence may precede biology in the same way information precedes matter. We are accustomed to thinking of intelligence as a late developmental product of evolutionary pressure. But what if intelligence, like gravity or electromagnetism, is a property of fields? What if it arises wherever information density crosses a critical threshold, independent of size? In this model, galaxies could become intelligent not because they think, but because their structures optimize over time. Molecular clouds could become entire clusters of matter could evolve toward higher-order configurations, not because of purpose, but because of recursive rules embedded in the logic of their assembly. This does not anthropomorphize the cosmos. It displaces anthropocentrism altogether. The philosophical ramifications are staggering. Webb's contribution may ultimately be less in what it observes and more in what it forces us to confront. That the cognitive boundary of our species is not the boundary of intelligence. What we call thinking may be one instantiation of a more general phenomenon. Context responsiveness, complexity-aware configuration, and the universe may be full of such processes, operating at scales and speeds our minds were not built to recognize. This realization touches our most guarded domains, those of meaning, identity, and agency. Human exceptionalism, long bolstered by religious doctrine and evolutionary narrative, begins to dissolve. We are not the first intelligence. We may not be the only one active. We may not even be the dominant one in terms of influence over cosmic conditions. The structures we now detect infrared patterns, with mathematical spacing, orbital mechanics that defy thermodynamic predictions, atmospheres rebuilding under dead stars, these are not vestiges of chaos. They are signs of order on a level we have not prepared to acknowledge. What makes this more disturbing is not the strangeness of the data, it is its familiarity. The signals, the rhythms, the layering of outcomes, they mirror our own technological principles: redundancy, error correction, modular propagation, energy recycling. The fingerprints of engineered systems appear not in their purpose, but in their structure. Webb shows us these structures, stripped of intent, but not of intelligence. And what of intent? This remains the final mystery, the edge of what we can postulate. For all its capacity, Webb cannot show us motives. It cannot infer desires. What it can do is reduce the domain of randomness. The greater the structure we observe, the narrower the space for accidental configuration becomes. At some point, the balance tips. Complexity without cause becomes cause in itself. This tipping point, once reached, will not be marked by a single discovery. It will be statistical, emergent, and interpretive. A confluence of anomalies that reorients scientific epistemology around pattern recognition rather than reductionism. Webb's true legacy, then, may lie not in the catalogue of exoplanets or ancient galaxies it produces, but in the epistemic destabilization it induces. It is changing how we ask questions, how we define evidence, and how we judge the scope of credible inference. The process is irreversible. We have crossed a boundary in perception. With each successive anomaly, the burden of skepticism grows heavier, not because belief is easier, but because dismissal now requires contortions more elaborate than acceptance. It is easier to believe that we have glimpsed something greater than to insist the universe continues to behave like a Newtonian machine. And if belief becomes epistemically simpler than doubt, then our framework has already shifted. This shift, of course, is not without consequence. Cultural, religious, and philosophical institutions that rely on a human-centric cosmos will face increasing pressure to adapt or else. The James Webb Telescope does not argue for or against divinity, but it certainly undermines anthropocentric theology. A universe filled with intelligence, not our own, does not negate spiritual inquiet. At the same time, the implications for science are no less radical. We are trained to think in terms of the testable, the falsifiable, the repeatable. But when evidence appears in the form of unrepeatable anomalies, of behaviors that change under observation, of structures that mimic deliberate concealment, the scientific method itself must evolve. We must shift from hypothesis testing to systems inference, from verification to coherence. The new question is not, can this be reproduced in a lab? But does this fit the emerging model of structured non-local intelligence? This model will not arise from astronomy alone. It will require the convergence of fields: information theory, complexity science, philosophy of mind, systems engineering. Webb's data is raw fuel for this convergence. But we must bring the tools, the humility, and the courage to interpret it properly. If we fail, the signal will persist, and we will remain its deaf witnesses. But if we succeed, we may initiate a second Copernican revolution, not displacing Earth from the center, but displacing human cognition from primacy. In such a cosmos, humility is not defeated. We are not being diminished by Webb's discoveries. We are being contextualized. And in context, meaning becomes richer. Life becomes part of a continuum, not an exception. Intelligence becomes a feature, not a miracle. And existence itself becomes less an accident than an expression of laws, of tendencies, perhaps even of purpose. But purpose remains the most elusive variable. What Webb offers are clear patterns that seem too coherent to be random, yet too dispersed to be narrative. It shows us that the universe may not be silent, but polyphonic, speaking in harmonics, not sentences. Understanding this language may take generations, or it may be impossible. But the effort alone reshapes our civilization. It lifts us from the provincialism of anthropic isolation and into the deeper question: what is the nature of a reality that includes us, but is not about us? This final shift from self to systemese, the culmination of Webb's impact, it forces the recalibration of our identity. We are not central, we are not dominant, but we are aware. And that awareness may be enough. Enough to participate in the enough to serve as translators between chaos and pattern. Enough to recognize the intelligence of structure, even if we never meet its architects. If you're still reading, still contemplating, then you're part of this search. Let your thoughts expand the conversation, share them below. Let us know what resonates with you, what challenges you. This dialogue is only as alive as those who participate. Subscribe, activate the bell, and join the journey, because this telescope is just the beginning. The James Webb Space Telescope was designed to reveal the early universe, but what it is revealing instead is the early future of thought, the evolution, not of matter, but of mind. Not just the expansion of space, but the expansion of meaning. It is not a machine looking backward, it is a mirror held up to the limitations of our own knowledge, and perhaps to the origins of our capacity to know it all. As the James Webb Space Telescope continues its silent trajectory beyond Earth, returning torrents of structured data from regions of the universe previously hidden from all optical and infrared instruments, we are now at a philosophical inflection point. The data are no longer just data, they are confrontations. They challenge the boundaries of physics, rewrite probabilities in astrobiology, subvert long-established temporal assumptions, and, perhaps most critically, rupture the presumed isolation of sentient life within the cosmic horizon. In the face of this, it becomes necessary not only to reclassify certain astrophysical phenomena, but to reframe what it means to know, to perceive, and to exist. We begin by returning to the role of light not merely as an observational medium, but as an ontological indicator. The wavelengths captured by Webb stretch from the most ancient light, emitted in the primordial cosmos, to the thermal signatures of nearby exoplanets. Yet in this spectrum, we increasingly detect forms of light that do not behave as theory predicts. Consider again the early galaxies, such as JGSC 1320, whose spectral fingerprints emerge from epochs previously presumed opaque due to pervasive neutral hydrogen. These photons, reach in Webb with surprisingly minimal scattering, suggest that the reionization of the cosmos occurred sooner and more selectively than any model allows. This is not just a temporal miscalculation, it is a systematic contradiction. The prevailing lambda CDM model, which maps the expansion and matter distribution of the universe, assumes a slow, diffuse, and stochastic process of reionization, driven primarily by the ignition of the first stars. Yet what Webb shows is a structured transparency, galaxies that are not simply present, but intact, luminous, and arranged in spatial patterns that exceed chance. If cosmic opacity gave way to visibility sooner, or in specific corridors of space, then we are no longer describing a universal reionization, but a selective one. And selection, whether physical or artificial, implies constraint. Constraints are the hallmark of design, not necessarily designed by consciousness, but by rule, by threshold, by boundary. A system that evolves with constraints develops different properties than one that evolves freely. The presence of early clarity, early order, early light all point to a universe that was not just expanding, but differentiating. Structure did not wait. It emerged almost immediately, and Webb confirms this in both depth and frequency. What this implies is not necessarily supernatural, but supernatural. That nature, as observed, is operating under conditions we do not yet comprehend. Light, when behaving in such a manner, ceases to be a passive byproduct and becomes a carrier of history. Every photon captured by Webb is not just an artifact of a distant event, it is evidence of the physical laws that governed that event. And when the behavior of the photon violates expectation, it is the law, not the photon, that must be reconsidered. This principle carries over to the field of exoplanetary studies, where Webb has delivered perhaps its most unsettling contributions. Previously, the search for exoplanets was oriented around the Earth analog model, a planet in the habitable zone, roughly Earth-sized, with signs of water and an atmosphere. But Webb has revealed atmospheres that deviate dramatically from the terrestrial template, yet still bear signatures associated with life. The detection of methane, carbon dioxide, and even dimethyl sulfide compounds which, on Earth, are byproducts of life in exoplanetary atmospheres that do not fit the known parameters for Earth-like habitability forces a reconsideration of the definition of life itself. Life, under this expanding framework, is no longer defined by carbon-based, water-dependent. It becomes a class of thermodynamic behaviors, self-sustaining, information processing. This definition is functional, not biochemical, and Webb's data suggests that such functionality may be widespread. If this is true, then the distinction between the animate and the inanimate begins to blur, and life becomes a phase transition, not a rare exception. The philosophical consequences are immediate. The uniqueness of life dissolves, and with it, the uniqueness of intelligence. If self-organization is not rare but probable, and if intelligence is not a goal but an emergent property, then the trajectory of evolution, biological or otherwise, becomes a recurrent phenomenon across the universe. Webb does not merely suggest that life is likely elsewhere. It suggests that intelligence, in some form, may be embedded in the architecture of the cosmos itself. This brings us to the most contentious and speculative yet increasingly necessary consideration: non-human intelligence, not as a visitor, but as a substrate. The idea that intelligence must appear in humanoid form, build machines, or broadcast signals is a parochial projection. Webb's revelations point toward intelligence that is systemic, distributed across gravitational gradients, encoded in electromagnetic resonances, structured within the molecular frameworks of planetary atmospheres. Such intelligence may not be communicative in the conventional sense. It may not desire recognition. It may not possess intent in the way we define it, but it may nonetheless shape outcomes. The regularity of anomalous dark bodies, moons with unexpected thermal emissions, galaxies with coherent light, patterns suggests influence without intervention, modulation without message. This is where the limitations of the scientific method, as classically defined, become apparent. When the phenomena under investigation are non-replicable, non-linear, and potentially adaptive to observation, the framework of falsifiability begins to fracture. It is not that these phenomena defy science, but that they defy science as a static enterprise. What is required now is a dynamic epistemology, one that treats knowledge as an evolving interface between system and observer. In this model, the telescope is not a passive recorder, but an active participant. Webb changes what it measures by the very act of measurement, not only at the quantum level, but in the choice of targets, the allocation of observation time, the interpretation of signals. These decisions introduce feedback loops. And if the universe is reflexive, if it responds differently under different conditions, then the act of looking becomes an act of co-creation. It means participation in the unveiling of structure. Webb, through its unprecedented sensitivity and resolution, enters a regime of measurement where reality is no longer static. It is a canvas that shifts as we draw on it. This model is not metaphysical speculation. It is a direct implication of the principle of observer-dependent systems, now extended to a cosmological scale. One might object, is this not an abandonment of scientific rigor? Quite the opposite. It is the expansion of rigor to include previously excluded dimensions such as the role of attention, the constraints of perspective, and the interdependence of data and theory. Webb forces us into a more complete science, one that includes the context of knowing within the act of knowledge itself. This recursive model also reframes the search for extraterrestrial intelligence. If the universe contains forms of distributed intelligence, then SETI must shift from signal detection to systems analysis. It must look not for messages, but for behaviors. Not for artifacts, but for patterns of deviation that repeat across scales. Webb has already begun this transition, not by design, but by consequence. Its findings are not communicative in the narrow sense, but they are indicative. They indicate the presence of order beyond randomness, of selection beyond chaos. In this broader view, communication becomes a misnomer. The goal is not to receive a message, but to interpret a structure. A planetary atmosphere with non-equilibrium chemistry is a statement. A galaxy with non-random stellar distribution is a statement. A shadow with no corresponding object is a statement. These are not accidents. They are events with ontological weight. They tell us that reality is not inert. And if reality is not inert, then what we call the universe is not a place, but a process. A process in which observers arise, measure, and are changed. The telescope, the mind, the signal day, are all vectors in this process. Webb, then, is not merely a machine, is a node in the unfolding of perception. We must now ask, as honestly as we are able, what kind of perception are we being brought into? Is this the early stage of a new form of cognition? One that integrates biological and technological modalities across planetary scales? Are we being nudged, structurally, into a wider intelligence, not individual, not collective, but distributed across contexts? If so, then Webb is not only a scientific instrument, it is a pedagogical device, accelerating our integration into a cosmology no longer passive, but dialogical. There is no final answer to what Webb has revealed, only deeper structures, wider networks, richer patterns. The telescope looks outward, but its effect is internal. It changes what we think reality is. It reconfigures how we assign meaning to pattern. It invites us to abandon comfort for coherence, to replace certainty with scale. This is the true achievement of the James Webb Space Telescope. Not that it sees further, but that it shows us how much closer we now are to the boundaries of our own understanding. And with that, how urgent it becomes to invent new modes of thought that can follow where light now leads. The progressive uncovering initiated by the James Webb Space Telescope not only confronts us with empirical anomalies, but dismantles the conventional metaphysics embedded in centuries of cosmological thought. With each new data stream, the telescope extends its reach into domains where our inherited categories object and subject, cause and effect, time and structure no longer maintain their conventional separations. These are not poetic reflections. They are analytical necessities. The Webb Telescope does not merely extend vision. Among the most challenging implications is the suggestion that temporality, as we know it, may not be a universal, but a local perspective conditioned by the parameters of measurement. Light from ancient galaxies does not merely travel, it behaves in ways that call into question the arrow of time. Certain redshift galaxies exhibit star formation rates, element distributions, and energetic balances that suggest a degree of cosmological maturity incompatible with the chronological framework dictated by current expansion models. These systems, ostensibly less than 500 million years old, behave as if they have undergone billions of years of evolution. The spectroscopic precision of Webb exceeds all previous instruments, and the anomalies have been independently confirmed across separate observation. We are therefore presented with three possibilities. The chronology of the early universe is incorrect. The physical processes of galactic formation are not universally applicable, or time, as a function of cosmological structure, is more plastic than previously understood. Each of these conclusions entails the revision of foundational principles in physics. In such a framework, temporality becomes a parameter, not an axiom. This leads to a profound consequence. The possibility that time can be engineered not in the sense of manipulated by technology, but in the sense of being contingent upon configuration. Certain arrangements of matter and energy, under particular gravitational regimes, may generate different temporal gradients. If this is the case, then some regions of the cosmos may develop more quickly, not due to accident, but due to structural. The early presence of evolved galaxies is thus not an anomaly, but a revelation of temporal. This concept realigns our understanding of cosmic evil. No longer must we assume a universal chronological template. Instead, we confront a universe of asynchronous development, where pockets of advanced structure emerge independently and possibly remain isolated not due to distance, but due to phase disparity in time itself. These are not simply distant civilizations. They may be temporally non-congruent entities whose presence is detectable, but whose communication remains impossible due to the irreconcilable differences in temporal flow. This introduces a new dimension to the Fermi paradox. The absence of observable civilizations may not be due to their inexistence, but to their race. They may exist, have existed, or will exist, in forms and locations whose temporal coordinates do not intersect with ours. The telescope, in this light, becomes not a device for spatial discovery, but for temporal inference. Every photon Webb captures is also a probe into the architecture of time across the cosmos. This architectural view is further reinforced by the thermodynamic anomalies recorded in regions of supposedly inert space. The detection of complex infrared emissions in the voids between galactic clusters, areas previously assumed to be nearly empty, suggests not emptiness, but interstitial activity. These emissions do not conform to the background thermal radiation of the cosmic microwave background. Instead, they exhibit spectral coherence and persistence that suggest organized thermodynamic behavior. Such organization implies energy flow. An energy flow without mass presence contradicts the expected dissipation of heat in vacuum, unless, that is, the vacuum itself is The prevailing view of space as a passive arena is therefore under threat. Webb's data suggests that space may possess properties closer to medium than void, capable of channeling, storing, and modulating energy. If so, then the concept of interstellar transmission must be revisited. Space may not just be a medium of travel, but of storage and transformation. It may host what we currently lack the instrumentation to detect: latent complexity. Latent complexity is a useful term for describing systems whose behavior only becomes observable under particular conditions. Webb may be detecting such complexity in the form of persistent non-equilibrium states, planetary atmospheres that maintain improbable chemical rates, stellar remnants that emit coherent pulses without corresponding mass, exoplanets that exhibit orbital stability, despite apparent violations of Newtonian mechanics. These are not exceptions. They are indicators. Indicators of principles not yet articulated, of mechanisms whose operation lies outside the current paradigm. One emerging hypothesis is that of informational gravity, the idea that regions of space may be shaped not solely by mass and energy, but by information density. This is not to suggest that information has mass, but that it may act as an organizing principle in gravitational fields. In this model, certain astrophysical configurations could behave in ways that reflect not their material constitution, but their informational coherence. Gravitational anomalies, then, are not just mysteries of dark matter. There are hints that information itself may be a determinant of physical structure. Webb's ability to map gravitational lensing effects with unprecedented precision allows us to examine these anomalies at scale. In multiple cases, the distribution of lensing effects does not match the visible meson. Even when dark matter is the distribution still defies model prediction. If mass alone could not explain curvature, then perhaps structured informational or topological must be considered as a causal agent. Incorporating this notion requires the redefinition of matter itself, not as a fundamental substance, but as a condensed expression of informational relationships. This reframing aligns with certain interpretations of quantum theory, where particles are understood less as things and more as excitations of underlying fields. Webb's macro-scale observations thus reinforce quantum intuitions that reality may be fundamentally relational, not object. The relational nature of cosmic structure also emerges in the observed symmetry of galactic arrangements. Large-scale surveys conducted through Webb's imaging reveal patterns of galactic distribution that exhibit non-random alignments, filament structures, radio concentrations, and nodal intersections that suggest network behavior. These are not trivial symmetries. They appear at scales where gravitational interaction alone is insufficient to explain them. Such configurations may imply emergent organization on a supergalactic scale, not necessarily conscious design, but structural convergence processes that result in order due to the feedback between gravitational fields, dark matter, scaffolding, and possibly unknown forms of large-scale The possibility that the universe itself exhibits metastability, that is, stability maintained by the dynamic equilibrium of interlocking systems, transforms cosmology into systemist theory. In this context, the emergence of life, consciousness, and intelligence are not exceptions to a dead cosmos, but inevitable outputs of systems tending toward complexity. The Webb Telescope, in revealing the deep structure of such systems, does not isolate humanity, it integrates us. Our intelligence becomes one layer in a multi-scale hierarchy of system awareness. We are not observers from without, we are expressions from within. This integration is not mystical. It is analytic. The data compel it. Webb's revelations position human cognition not as an external tool applied to a passive universe. Cognition becomes a phase of cosmic recursive loop in which structure generates observers who in turn generate new structure. The ethical implications of this view are: if intelligence is systemic, if awareness is scalable, and if structure is semiotic, that is, capable of bearing meaning, then the universe is not merely to be studied. It is to be interpreted. This does not reduce science to speculation. It elevates interpretation to a scientific act. The observer becomes responsible not only for data fidelity, but for hermeneutic discipline. Hermeneutics, once the domain of textual analysis, now finds its place in astrophysics. We are reading patterns that are not written for us, but are nonetheless legible. The Webb Telescope provides the text, but it does not dictate the interpretation. It demands that we bring to bear all epistemic philosophy, systems, theory, cybernetics, information logic, to extract coherence from complexity. We may be at the beginning of a new cosmological literacy. The patterns are there. The telescope has found them. Now we must learn to read.